So good afternoon, everyone. So welcome to day 2 of the conference. Okay, so I will come here. So yesterday we had some very nice talks from several speakers. We will follow it up with day 2 of this conference today. And this session is going to be chaired by Mr. Sandeep Anand. I would request him to take over and conduct the session.
Hello everyone, and thank you, Professor Amit. So after the very fruitful yesterday's session, let's sort of start today's session. Just before we do that, let me share. Here at IIT Bombay, it's heavily raining outside, and sometimes you might also hear some background noise of the rain pouring in. It's a virtual experience for all of us. So in this session, just a quick logistics part. So each speaker would talk for 20 minutes and then 5 minutes for Q&A. If anybody has any question, then please feel free to write in the chat box. I'll take it up towards the end of the discussion for each speaker. Let's start with our first speaker for the session, Professor Siddhartha Mukhopadhyay. Professor Mukhopadhyay is a professor and head the Department of Electrical Engineering and also head of the School of Energy Science and Engineering at IIT Kharagpur. His research interests are in electric mobility, integrated vehicle health management, aerospace tracking, and cyber physical systems. He has been working on working with various national and international industries over the last couple of decades. Some of his recent work includes on plug-in hybrid electric vehicles. So I would request Professor Mukhopadhyay to please share his screen and start with the presentation.
Yeah, thank you, Professor Anand. So first of all, very good morning, good afternoon, and good evening. It is indeed a pleasure and a privilege to be able to present to an audience across the globe. I will start sharing my presentation. So let me see. I choose screen 1, right? And then share. And then let's go here and present. Are you able to see my screen?
Yes, sir, please.
Yeah. So let me begin. I propose to talk energy management. Interesting point is that I want to brought out is that it has a very large number of dimensions and a way of integrating everything into an architecture. So before I generally like to make my acknowledgements before the talk. So I acknowledge the support from a national project which is funded jointly by an industry and government in India, and my institution folks and authorities, specifically 2 of my students who have helped me put up this talk, and some material and pictures I have used from the free internet, which is without reference citations to those. So talking about hybrid electric vehicles, everybody more or less knows what they are. Just to put in perspective, this is a conventional vehicle powertrain. When you have a hybrid vehicle, then you bring in a motor. This is one way of mounting it on the shaft, and you drive it with a battery and some power electronics. This architecture is a parallel hybrid architecture. there could be a series hybrid architecture, which we'll not talk about here. During the what is critical to understand is that during the operation of the vehicle continuously switches modes. There are several modes of driving the vehicle. It could be run from the engine only, the motor only, or by both together. Or it is possible that the engine will be driving the vehicle and it will be simultaneously charging the battery. Or if your velocity is coming down and you're braking, then you could recover some energy by regeneration. So here we are showing that this is what is known as a drive cycle, which is basically a velocity versus time plot of the vehicle. So it shows that as the vehicle moves through traffic, and sometimes its velocity increases, sometimes decreases, the vehicle continuously switches modes and operates in each mode. So for example, if you see while its velocity is sharply falling, it is operating in the regeneration mode, which is mode number 5. So it is this switching between the modes and the consequent flexibilities of operating it in various modes in various ways that leads to the basic energy efficiency of the vehicle. So this shows that picture that the motor, it's a parallel hybrid, so there are two propulsion sources. These are torque speed curves, so you could have several operating points and you can choose from them. So you can choose which operating points you choose to drive the engine in and to drive the motor in to realize the overall the torque demand which comes from the driver. So there is what is known as there's what is known as a degree of freedom. So we know that if you want to optimize anything, then you need a degree of freedom. It turns out that electric vehicles which do not have gears do not have a degree of freedom. If you need a torque, you have to operate the motor at a certain point. If you have a vehicle with a gearbox, then you have 1 degree of freedom because you can choose the gear, and to some extent you can change the torque speed operating point of the engine itself. If you have a parallel hybrid, then you have your degree of freedom as 2 because you can choose the gear, and you can also choose that at any gear position, what is the this is called a torque split ratio. So how much torque at that gear you want to realize from the engine and how much you want to realize from the motor. That is in the hand of the optimizing algorithm. So it has 2 degrees of freedom. So when you have degrees of freedom, then you can optimize. And it is this that leads to energy efficiency of the vehicle apart from regeneration. In regeneration, there is an inherent advantage that you can generate some part of the kinetic energy back to the battery. So now so this leads to a prospect of an optimal energy management. So this is roughly a block diagram for that. So you have the vehicle here. This is the energy management strategy which gives the command of the optimal gear and the optimal engine and motor torques that are to be realized from the vehicle. So there are the engine controllers, there are the motor controllers. So the energy management strategy sends the commands to these controllers and say realize this many Newton meters from the engine, this much from the motor. Now how does it do that? So it has to meet the net torque demand because we are assuming that we have to meet a certain velocity profile. So the net torque demand is actually calculated, and then based on so this, to be able to calculate this torque demand, you need various other inputs, like you need what is the traffic, what is the traffic condition, you need what is the terrain condition, you need what is the temperature, etc. And you need the powertrain characteristics. So if you have this, then you can generate the net torque. Once you have, and then you start, and then you try to realize this net torque in the best energy efficient way, and you can actually do a sophisticated numerical optimization to generate these commands using various models. So there is a scope of a model-based optimal energy management, and this is what makes the hybrid vehicles more energy efficient than conventional vehicles. But you have further choices. So for example, there are ways, so we said that this net torque demand has to be met. But the net torque demand can itself, actually itself depends on the let's say the aggressiveness of the driver. It depends on the traffic. It depends on the terrain. And it of course depends on the route. So there is a way of optimizing these things further to actually limit the mechanical energy which is required to get the vehicle from, let us say, point A to point B. So if you really wanted to do extract the maximum amount of energy efficiency from the overall system, then it becomes apparent that you cannot stay in the car. The car, this was the low-level controller that we just described, which basically takes signals from whatever is there in the car. But you cannot stay in the car, because you need to know, if you want to really optimize for a trip, you need to know at what velocity and acceleration profiles you are going to move. You need to know what kind of charge replenishment you need to do to the battery, and various other stuff. So you need to aggregate and compute information from a lot of other sources and make a velocity forecast, and use a driver style. You can learn the behavior of the driver, and you can know how the driver drives, and you can know the health and the condition of the battery, and what kind of demands will be placed on the battery for the whole route. And then you have to use a high-level controller which will provide certain informations with which the low-level controllers will work. So it turns out that the energy management problem cannot be solved just staying within the car. So that is a very interesting observation. So you need various kinds of infrastructure. You need cloud computing infrastructure. You need various kinds of services to be able to actually give the customer the least cost of actually driving the vehicle. That's the key point that I'm trying to make. So it turns out that the high-level controller has to, once you have specified a route, now we often travel with respect to maps. So when you travel the route, you need to segment the route. Across segments, you can make some assumptions about the traffic, the terrains maybe. So based on traffic, terrains, traffic lights, etc., you can make segments. And then you need to do a high-level optimization to actually decide the charge references which you need to provide to the low-level controller. That becomes very important, because there are some situations will arise when you need both the engine and the motor to run. So for example, look at I hope you are able to see my mouse. So it turns out that the blue line in this plot actually indicates a terrain. So you see that the vehicle moves on level road up to this point, and then beyond this point it starts climbing some slope. So when it climbs the slope, it needs both the engine. The torque demand goes very high, and it needs both the engine and the motor. So it's important that before you arrive at this slope, you have a certain amount of state of charge. So if you don't look ahead into the terrain and the traffic, then you might use the battery in a way that when you come here, you will not have enough state of charge left, and then you will be stuck. You cannot climb the terrain. Similarly, there are regulatory zones, especially in the developed countries, in cities where you have some zero emission zones where you need to run the vehicle, if you want to use the vehicle, only on the motor mode. You cannot switch on the engine by regulation. So even for those, you need to. So you need to, when you are doing energy management, you need to operate the vehicle in a way such that when you arrive at these zones, you have enough charge left. So that should be part of the energy management. So, for example, this is just a simulation. So it shows that this ECMS is actually a very popular energy management strategy which has been implemented in certain vehicles. So again, we have an elevation, and you can see that the blue curve actually doesn't look ahead, and so it starts using the energy in a greedy manner, and tries to optimize instant to instant. So if you see the battery SOC, it actually uses the battery SOC very aggressively in order to keep the fuel cost low. And therefore, when it comes, so in the middle of the slope, it actually runs out of battery charge, and then it has to stop. But the red strategy, it actually builds in fuels and builds in the SOC enough so that it can actually traverse the whole slope and actually complete the journey. So you need to do these things for the best customer experience and for good energy management. All right. Now, how do you implement all that? So it turns out, so here is the vehicle. So you have an engine, you have a motor, you have a clutch, you have a transmission, and for each one of them you have a controller, and you have a vehicle control unit which actually, as we said, it gives commands, and it continuously talks to the subsystem controllers using over a CAN bus typically. And so this is the unit which actually does the energy management. So, but to be able to, as we said, that to be able to manage energy effectively, it has to talk with something like a ADAS, which may be actually integrated with autonomous sensors. Let's say some cameras, radars, lidars mounted on the car, because these can give you local information around the car, and it can give you a reliable data so that when you are doing predictive energy management, you know that there is a vehicle which is actually cutting into your lane, and you will need to bring down your velocity. So the target velocity profiles in the short range may be provided from the automotive sensors. On the other hand, you may have a telematic processor which will give which is connected, let us say, with some cloud infrastructure, and let us say with some traffic infrastructure like smart poles on the road. And using these telematics, you will be able to you can use this for that high level optimization. So you actually, to be able to do energy optimization of the vehicle, you need information from so many sources, and you need to have this sort of a processor architecture. So what do you get? I mean, what kind of? So just I thought that it'll be interesting to compare. After doing this, what do you get? So this is a comparison between two Indian cars. One is a Tata Nexon EV, and the other is sorry. Happening here. So and the other is a conventional ICE. They are the same profiles. So they are drag coefficients, weights, etc. Everything same. You see, there are a lot of numbers here, so it may be difficult for you. So first look at this, that the costs of the cars, the EV costs almost double. That's because of this 30 kilowatt hour battery that is needed. But it gives it gives very good drivability. So the main problem is that of course the battery. Everybody knows it's very expensive and its life is smaller. I mean, tends to be shorter than that of the vehicle. Of course, technology is trying to catch up and try to solve these problems. So that's the situation. On the other hand, we tried to compare a Toyota Corolla Cross, an HEV and an ICE. It turns out that their costs are nearly same. One is lakh is an Indian unit. It means 10 to the power 5. So this is 23 in 10 to the power 5, and this is 24.5 in 10 to the power 5. So you can see that they are nearly same. The battery is actually a 4 kilowatt hour battery, 600 volts and 6.5 ampere hour. While just by doing the energy management that I was talking about, you see the energy efficiency that they are gaining is quite substantial over the IC. So I always thought that in the short term, India needed an HEV because it needs a shorter battery, and while the CO2 emission is not very much cut down, but you see from 150 it has come down to 100. So it's environmentally somewhat friendly as well. So that's the last slide. So my concluding remarks are that there is a degree of freedom available in the HEVs using which you can really do optimization in real time and bring down the energy costs significantly. And it's critical to actually justify the additional costs over the HEV life cycle because the maintenance cost is going to be slightly higher and the actual cost is higher. Potential management, a confluence of infrastructure and technologies are needed to operate in synergy. So you actually need a cloud infrastructure. You could need some autonomous sensors to get the full benefit of energy management. And interestingly, such systems, this whole system is not in place. Of course, they are getting developed, and this presents a major research gap to be filled in by XCV research. So that's it. Thank you very much. I would like to take some questions if you have. Expand panel to show video. No. Where am I? Okay, let me stop sharing my screen first. Yes.
Yeah, so please, if there's any question, feel free to type it in the chat box. We can take one maybe quick question. Yeah, I have one of my own, so maybe I'll go ahead with that, and I'll wait for others to join in if they have. So, Professor Mukhopadhyay, you talked about hybrid, and you showed an example of a four-wheeler, right?
Yeah.
How are your thoughts about two-wheelers, especially if we consider, let's say, some of the other countries which are predominantly depending on two-wheelers? Right?
Yeah. So EV is much more suited for two-wheelers because the battery requirement is really low, and two-wheelers really do not have space. So it's very difficult to actually fit in the engine and the battery together in the two-wheeler and the motor. So for a two-wheeler, I think clearly the EV is the right solution, and it is being shown. I mean a lot of electric two-wheelers are kind of coming to the market, but that's not happening for the four-wheelers in our market. Yeah. So two-wheelers, yeah, EV has a better case. But the main point that this talk wants to show is that even for EVs, you can actually drive the vehicle in a way which can save a lot of energy. Yeah.
Right. Sure. Thank you, Professor Mukhopadhyay, for the nice presentation. We'll even if there are other questions, they can type it in the chat box. We can take it later. We'll move on to our next speaker. Our next speaker is Professor Yong Lee. Professor Yong Lee, I would request you to please share your screen. So Professor Lee is a full professor at Yunnan University in China. He is also the director of the Engineering Research Center for Power Transmission and Transformation Technology. His research interests are power system stability, analysis, control, AC/DC energy conversion system, analysis and control of power quality, HVDC, facts, etc. I would request Professor Lee to please go ahead with the presentation.
Okay, thank you. Nice to meet you, everyone. It's my pleasure to share our research works about the efficient charging technology for electric vehicle. Okay, and I will make my presentation from the 5 parts. The first is background and significant. In China, actually, the government worker report of the State Council in 2020 includes electric vehicle charging health into the category of new infrastructure. So, in China, the government provides the strong support for the long-term and stable development of country's automobile industry. And for the charging safety, it's very important. Charging safety is a fundamental issue for the electric vehicle. But the current charging technologies has some limitations, such as the charging mode of the power module is inflexible, and unsafe quick charging or overcharging can easily lead to battery thermal runaway. So actually, the charging technology plays an important role in promoting the safety of EVs and improving user experience. However, for the charging equipment, there are some limitations. The bidirectional power flow is not realized in many power modules, and it's difficult to further improve the efficiency and the power density of power modules based on silicon devices. So, considering the mentioned background and significance, our team has performed the research from the 3 parts. The first is SOC estimation of the iron battery. For the state of charge estimation, we proposed the RNN combined the PSO to improve the accuracy of SOC estimation and has a good generalization ability on driving circle data set of different temperatures. So this is a structure of the RNN and the PSO-RN combination, and some the flow chart of the algorithm here. We have do many the experiment to validate our estimation algorithm and compared with the current data driving method. Actually, the PSO-RNN method can reduce the error within 2%, and the SOC estimation of the proposed method is more robust and accurate. We can see the figures about the SOC error, and also these figures indicate the performance of the algorithm. We also test our algorithm at the different conditions, such as the different the temperature and such as the different the data set in different countries in China and in USA. So, in summary, the PSORN method has good robustness at different temperatures. The second part, I would like to introduce the charging strategy of lithium battery. Actually, here we investigate the multi-stage constraint current charging strategy. For this strategy, it can be segmented by the charging cutoff voltage. We first segment by cutoff voltage and the charging curves. We can see the figures here. Compare the traditional CCCV charging profiles. The MSCC charging profiles is flexibility. It can provide the flexible charging charging process to improve the charging performance. We propose some the metrics for the charging performance, such as we evaluate the charging performance by the charging capacity, charging time, and the charging efficiency. So actually, for the charging current optimization, it's a multi-factors optimization problems for different objectives. So to address the optimization problems, we use the Takeshi method to solve the optimal charging current combination. This method is an experiment-based method. The core of this method is the orthogonal array under the factor effect evaluation. Here, we can see from the table, the charging process is divided into 5 segments, and each current contains four levels here. We can see the first step orthogonal experimental result, and here the charging current in the fifth stage is weighted as a significant factor of the capacity and time. And the second level is the optimal value. The capacity and efficiency are maximized by the charging current in the first stage, and the first level is the optimal value. So here we optimize the charging current at a different stage. Also, we do the second experiment Here we fix the charging current in the fifth stage and update the factor level. Similarly, the result of the second experiment can be shown in these figures. According to the experiment, the capacity and the efficiency can be optimized by charging current in the first stage, in the second stage. So we have do the comparison with the traditional CCCV method, and we can say that the optimal charging current has advantages in charging efficiency, such as the cut-off current in different level. The efficiency can be increased in different the cut-off current, and more important, this method can reduce the maximum temperature of the battery. So this is the advantages of the charging strategy. Also, we compare the method with the exciting the MSCC method. This is the result. For the time limitation, I don't talk more about this. And this is another the aspect to evaluate the charging performance of this strategy. Here, this is about the step of the hybrid charging strategy with the adaptive current method. Here, and we divide the charging process into three stages, named the CC, CV. And the first CC stage is the same as the traditional the CC CV method. After reaching the charging cutoff voltage, the charging current is reduced to enter the second CC stage. And for the second step, this based on the internal resistance of the battery, the current of the first CC stage in the hybrid charging strategy is adaptively controlled. For the second step, we also have established the models with the subjective, and the adaptive current can significantly reduce the charging loss and reduce the battery temperature rise. And also for the hybrid charging strategy, we performed the HPPC test at different SOC to obtain the internal resistance and the impedance. This is the result. Here we also do the comparison experiment and obtain some result to indicate the performance of the hybrid charging strategy. and for the okay, sorry, I adjusted here. Okay, for the optimal charging strategy with complementary path current control. When we study the optimal charging strategy, because for the fast charging, the advantage is to eliminate the polarization and accelerate the charging process. But it has two inherent flaws. The first is that the path interval actually prolongs the charging time, which reduces the charging performance. And the second reason is that the path current contains the AC component, which will cause an increase in charging loss. So for the optimization of the path frequency, the minimal AC impedance frequency is obtained by the AC impedance spectrum test of the battery, which is used as the initial value, and we also tried the online tracking of the optimal frequency based on the disturbance observed method for the frequency tracking here. For the method of passive frequency optimization, it's the same as the mentioned hybrid charging strategy. Actually, it's also based on the battery's internal resistance characteristics to optimize the charging current and to minimize the charging losses. Finally, we designed a path charger topology here with complementary charging current characteristics. Actually, which is composed of a controlled current source, path control switches, and anti-reverse diodes. It completely eliminates the prolongation of the charging time caused by the path loss. Here we also give the proposed duty cycle control flowchart here. And we carried out the experiment to verify the effectiveness of the proposed path chargers. This is the result here. And we can see from the waveforms, the proposed chargers has excellent path current regulation capabilities, and the power of the front and the rear stages is decoupled here. And also we do the comparative experiment to validate the proposed method and compared with the traditional path method. And we can see by this method, it can avoid the prolongation of the charging time caused by the path interval and improves the charging efficiency. Okay. So the last part is the charging converter of electrical vehicle. In order to reduce the charging losses, here the LLC resonant converter is designed, and actually the converter should be operated in the operating area where the primary side switches are turned on with the ABS and the secondary side rectifier diodes are naturally communicated. So there are some relationship between the switching frequency that meet the requirement here. And there are two soft switching boundaries of the LLC resonant converters. The ZVS upper voltage boundary corresponds to the maximum output voltage of the converter under the ZVS condition. When the circuit is in series resonant state of the reactance here. And in terms of the ZVS lower voltage boundaries, it corresponds to the minimal output voltage of the converter under the ZVS condition. This is also the characteristics analysis about the boundary here. And here we show the process of the calculation and the output the voltage at the upper boundary and the lower boundary. We can do some calculation here. We also do the experiment to illustrate the upper and the lower boundary for the LLC at the ZVS condition. So we also do some analysis about the experiment here. And at last, we propose a push-pull DC-DC converter with complementary active clamp to improve the charging performance of the DC charger. And we analyze the operating mode for the DC-DC converter at different operating status. And also we obtain some experiment result about this. In summary, supported by the K Research and Development Program of Hunan Province, China, we established the platform for the charging and the discharging test for the lithium battery, such as for this battery platform, we can develop the battery state monitoring, and also we can test the battery parameters. We also established the charging module research and development and electrical vehicle charging platform. This is a platform for the power electronics research and development. And in Hunan University, the campus, we established the demonstration for the charging station in the campus. Actually, this is a PV storage charging microgrid with smart building. This is for this demonstration project. So for the conclusion, we focus on the high efficiency charging technology of electric vehicle and carry out research in the fields of state of charging estimation, battery charging strategies, and the charging converters. And various charging strategies are proposed and or improved to increase charging flexibility and improve charging performance. We proposed a new topology of push-pull converter to address the shortcomings of traditional converter. This is related publications for the presentation. Okay, thank you for your attention. Okay. So any questions?
Thank you, Professor Lee. I think there is one question in the chat box. I'll read it for you. For SOC estimation, what kind of current profiles were used?
Okay, I will say here. For the SOC, for the SOC the optimization, we use the dynamic stress test. We consider actually this is a data-based data-driven method. So we considering the different the temperatures, and also we use the benchmark data set about the SOC data for this method. And such as the driving circle data set of different temperatures. Okay.
Okay. Yeah, thank you. I think if there is maybe other questions, you can please answer it on the chat box. Thank you very much, Professor Lee, for the presentation. I'll move on to our next speaker, who is from South Africa, Professor Wayanad Sten. Professor Sten, I would request if you can share your screen. Professor Sten is the head of the department and professor of the Department of Civil Engineering, and he's also the chair of School of Engineering at the University of Pretoria. His research interest lies in vehicle pavement interaction, accelerated pavement testing, pavement materials, civiltronics, and instrumentation. Request Professor Sten to please go ahead with this presentation.
Good afternoon, Chair, Prof. Anand. Thank you very much for the opportunity. I just want to check that you can see my screen at this stage.
Yes.
Okay, perfect. Then we'll continue from there. Thank you very much for the opportunity. I appreciate it. The topic of my talk this afternoon is e-mobility in transdisciplinary and rural applications. Now, firstly, I think it's important to thank the organizers, the Brics India World Conference, for this conference on electric mobility. because it's a very important aspect. There are really vital developments, and there are issues that one needs to think about and reflect upon in order to plan further opportunities, look at challenges, and look at limitations. Because no new venture is without challenges and limitations. And the narrative of my presentation this afternoon is because I am a civil engineer focusing on road pavements, focusing on transportation effects on these pavements. The narrative is that people need to eat and work and obviously therefore travel. And some reflections on the bigger issue around e-mobility. What does it mean from a requirements viewpoint? What does it mean from the larger Brics viewpoint? And some possible applications in this regard. So slightly different than some of the other technical papers who described very specific developments, which is obviously very important for this bigger discussion, looking a bit more at reflection on some of the issues. So if we have a look at the map that I shared with you, if you look at it, it indicates the share of people living in urban areas in 2017. I'm using quite a few screens from the UN World Urbanization Prospects and data sharing to support some of these points. And if we look at it, we can see that there is quite a large portion of the world that is urbanized, if you look at the higher percentages, but then you also see that there's quite a large portion of the globe where a lot of people do not live in urban areas. So looking at the applications and effects of something like e-transport on rural communities and more agricultural communities is actually quite an important aspect of what we need to do. So if we look at this distribution, which focuses on urban areas, then we get to the understanding that there are more than 3.7 billion people that are deemed to be rural inhabitants. So quite a large part of the 7.8 billion people on Earth living in rural areas. And just for context, because we are talking about Brics, this provides an indication for the 5 Brics countries of, firstly, what's called a road quality index. Now, we can have various discussions about what determines the quality of a road. How do we measure it? How do we optimize it? This is one of the ways of looking at it. And if we look at it, we see it ranges between values of 3 and 4.6 for the 5 Brics countries, with a global average of just over 4. So actually the Brics countries are not doing too badly in terms of general road quality indexes. If we look at the total road lengths in these 5 countries, you will see that it ranges between South Africa's 750,000 kilometers of roads, and this includes paved roads, unpaved roads, all roads in that country, which is incidentally, South Africa is the 10th largest or longest road network internationally. And from there, it increases to the 1.5, 1.7, 5, and 5.9 million kilometers of roads. So quite interesting to see that the 5 Brics countries are all within the upper 10 longest road distances internationally. So we've got significant road networks. Obviously with their own challenges, with their own requirements, with their own engineering linked to them, but very, very importantly linked to e-transportation and e-mobility. So asking a roads engineer, why are roads important? Because we cannot talk about e-mobility without looking at roads. If you do a search on Google or any other search engine and you ask why are roads important, then it's quite interesting to see a lot of images in this case, a lot of indications, but mostly you see people in the images, you see people data in the statistics. So roads are important because of people. If we did not have people inhabiting the world, then there was no reason for traveling. And then if there's no reason to travel, we do not need a road. So currently, we are sitting with around 7.8 billion people on the earth. We've got a total of about 64 million kilometers of roads on the earth, if we add everything together. And these roads are absolutely essential for livelihoods because the roads connect, and they don't only connect businesses, they connect for social reasons, for economic reasons, for commercial reasons, for safety reasons, to travel to hospitals and police stations, and for opportunities. If there's a road, there's an opportunity to start a business. If there's no road, it means you are confined to one area and you cannot expand your mind, your business, your social status, and so on. So roads enable our functioning as human beings. They enable us to do all of these things. But it's also important to understand that once we've got roads, yes, we can have people walking on those roads. That's obviously one way of traveling. But essentially, in a modern day, we develop roads to provide for transportation using vehicles. Different types of vehicles. Some vehicles may be manual vehicles, human-powered vehicles like wheelbarrows and bicycles and tricycles. But other vehicles are engine-powered. And the majority in the world currently is still based on fossil fuels. But as you have seen through yesterday's presentations, today and tomorrow, a major drive currently towards the electric type of mobility is happening. And that's why it's important to see how this links to rural communities, roads, agricultural developments. It is important to also understand that although the topic of the conference is e-mobility or electric mobility, in the transportation engineering area, pavement engineering area, we've got actually three concepts that are interrelated. And the focus is for me on mobility and accessibility, although connectivity also forms one of them. So for definition, mobility, so the mobility that we talk about, electric mobility maybe, that's an indication of the ability and the level of ease of moving goods and services. So if you look at it, it's the ability to reach an opportunity. And the examples will be systems such as interstate highways, major highways, bus rapid transport systems. So how can we make our communities mobile? Accessibility, on the other hand, which goes always for transportation engineers together with mobility, focuses on the quality and the efficiency of the travel. And this is mostly at the community and individual level. So it focuses on concepts such as the travel time, the travel costs, the travel options, the comfort, the risk, all important aspects if you talk with a normal commuter on their experience of a trip. So it's mobility and accessibility, two parts of this whole transportation issue. Connectivity, just as a third definition over here, focuses more on the relative location of an object to its destination. And all of you will know of cases where you live in an urban environment and you may live relatively close to your destination, but if your house is on the one side of a highway or a railway line and your destination is on the other side, then you may have a very low level of connectivity, although you may be 50 meters apart from each other. So there are various aspects that we should incorporate into our discussion around e-mobility. Another way to look at mobility and accessibility is in this graph over here, where mobility, we look at mostly the larger primary or trunk type of roads. So if those are major centers, towns, cities, and so on, the green ones are smaller towns, and the red ones are villages or small centers, mobility will focus on how do we travel between these major centers, while accessibility will focus on how does the local transportation becomes possible. And that's why, in my mind at least, we should not only talk about e-mobility, very important, but also e-accessibility. Because if you start to look at a lot of the smaller rural agricultural type of electric vehicles, we are focusing a lot more on electric access rather than electric mobility. In terms of this, electric mobility or e-mobility is obviously focusing on the whole electric powertrain technologies, which a lot of focus is on. But then very importantly, also in-vehicle information and communication technologies and connected infrastructure. And these aspects from a road pavement engineer viewpoint is sometimes more important to put the focus on, because this is the parts where we take these electric, hybrid, hydrogen fuel cell vehicles with very specific reasons, but we see how do they connect to our infrastructure, or how do we use data and information from them to support and improve the infrastructure that we are working with. If we look at some of the World Bank statistics, for instance, the reason why it's important to look at the bigger picture is if you look at something called the Rural Access Index, which has got a link to accessibility and connectivity, there's a relationship between the Rural Access Index for a country and the poverty incidence in that country. So quite importantly, and this is an old concept in terms of your transportation engineering, if you've got a good road system, it supports the economy, it supports social integration and everything. So having good electric transportation vehicles is only a part of the solution. You also need the road infrastructure to support them. Another aspect to think a bit about is something that we often hear about is called the digital divide, where the digital divide indicates in terms of the digital economy, where are the gaps in the world. And Nielsen had defined this as 3 stages of digital divide, being the economic part, where data is just too expensive, the usability part, where there's access to data, but it's too complicated for the user, and then empowerment, and this is an interesting one, where the available digital technologies are not used to their optimum. So too simple usage. You don't realize the power of the computer that you've got, so you just do basic typing on it. So various types of digital divides that we've heard about. But similar to this, in my mind, we can also look at the electrical divide. Electrical divide, partly looking at economic, where it's too expensive to obtain electricity for a person. The availability part, where there's purely just no electricity available. And then the beneficiation part. What do you do with this electricity when you've got it available? Are you only lighting a light? Are you charging a vehicle? Are you charging a cell phone? What is the beneficiation of this electricity? Because it's wonderful to have electricity, but if it's just in a wire and you don't use it to beneficiate and support the community, then it's really not of that much use. If we look in this regard, again, at some data, this is 2 images, the one showing electricity access, share of the population with access to electricity, and the other one shows us number of people without access to electricity. And yes, they are opposites of each other, but again, we can see that there are major parts of the world where we do not have electricity available. And that means that in terms of our e-transportation, we have to think about how to address this. Now, I indicated in the title that the talk also has got a bit of a transdisciplinary context. And it's quite important for me when we talk about something like e-mobility, e-transportation, that we also ask the questions about how does it affect communities? How does it affect the people who are using the transportation? So in terms of an example that I would like to share is transportation and food mobility. E-transportation, e-mobility, and food mobility. A very important question is to look at where are the food produced and where are the food consumed, because between production and consumption, we need some kind of transportation. And just to highlight that in terms of transdisciplinary, that's the research strategy where we cross disciplinary boundaries to enable the creation of a holistic approach answer, so that we don't provide e-transportation in an area, but there's not electricity or not a need, or the need is different than what we think. So in this context, if we look at the daily per capita caloric supply, this is in terms of food supply in the world. Again, we can see from very low calories to very high calories, there are differences in the world. And incidentally, the food scientists, transdisciplinary, tells us that a average person needs between 2,000 and 2,500 calories per day, kilocalories per day. And we can see that there are many places in the world where there are shortages in terms of the production of caloric supply. Sorry, I just need to, there we are, my next one. So then the next question is, and this links to poverty and food shortages and so on, this indicates the coefficient of variance of caloric intake. How much does people consume? And the higher the coefficient of variance of caloric intake, the bigger the level of dietary inequality. And again, it's interesting to see that there are coincidences between the areas of lower caloric supply and higher standard deviations in this regard, which tells us we've got a major need to transport food or to produce food in areas where there are low food production currently. And that links through transportation. But interesting again, if you say, well, why is that? Why do we need to look at food? If we look at the daily caloric supply of various countries and we compare that to the gross domestic product of those countries, there is a positive relationship between them. And yes, there are many aspects and factors that I do not include in the discussion now, but I don't think you need to be a major scientist to see that there is a strong relationship between that caloric supply and the GDP of a country. Obviously, it includes various other economic aspects. So getting food, transporting food from the source to the use is quite important. One example that I would like to highlight in this context, and it links to food transportation, e-transportation, as well as the bigger issue of what I said earlier, electronic data, digital data from the whole transportation process, is something that we have done at our Engineering 4.0 facility for the last number of years, and quite recently in terms of the development of smart avocados and smart tomatoes, devices that are collecting data on the experience during the transportation phase of these fruits between the source and the market, to focus on the effect of the transportation system, the accessibility and mobility on food quality. So in this regard, just a quick image of what some of our smart avocados look like. It's a 3D printed shell with a microprocessor on the inside. And as it is transported, in this case, a major route for about 1,800 kilometers in South Africa on a road context, we collect information that can be transferred to, for instance, the cumulative kinematic energy that one of those avocados will feel during the transportation trip. This data is not exactly for that trip, but from the data, we can start to see where's the areas, sometimes long distances, where there's very low kinematic energy, so very low possibility of damage, and where's the areas of very high energy, And these are the aspects of the transportation phase where there's a major possibility of damage to this food. So although I'm transporting it from the source to the market, if it arrives in the market in a damaged condition, it is obviously not good. This is the last part of that process, which now links more to the international type of transportation, where some of those smart avocados has been followed in a trip from Cape Town at the southern point of Africa, all the way, this was halfway through, all the way to Rotterdam in the Netherlands, with the same idea of, in this big transportation picture, where a lot of food and supplies are being transported. Each of these little icons is a ship at that stage on the sea. What is the effect of transportation conditions on this transport? Are there aspects where we are losing quality, where we are losing the benefit of the food, where the whole e-transportation system drops us? The last focus for me is to look at the UN SDG links, our social development goals. We all know about the 17 social development goals, and some of them may be very appropriate to what we are doing and to e-transportation, while others may not be that much related. But if you look at it and you match transportation with the sustainable development goals, you can see that there's a major number of these, looking at hunger, poverty, clean energy, economic growth, infrastructure, communities, life on land, and so on, where there is actually a very strong link between transportation and this sustainability part of what we are busy with. And in my mind, the move towards e-transportation is quite important in this regard. Just want to check because there we are. Then synthesis and way forward. I think e-mobility is a fact of life. We cannot get away from that. Electric vehicles, there are urban and rural applications, and changes in behavior is expected in this regard. We need to think about the issues around it. Issues such as where to get the electricity, the E in e-mobility, how to distribute this electricity, and how to design for the E part, for the electricity part in our system. Should we change the design of our road networks, of our infrastructure, of our road furniture, or how do we cater for this in a bigger environment? So together with all of these, we need to make sure that we've got a transdisciplinary effort where we ask the various users of this transportation what they need. We listen to each other, we understand the challenges and the limitations, and then make sure that we cooperate in providing a full system to all the users. To ultimately ask the question, does your work, whether it's e-transport, e-mobility, e-data, does it enable someone to have improved social or economical or security or educational opportunities? With that, my acknowledgements and thanks to Brics India World for the opportunity, and many colleagues and students and funders who obviously support a lot of our work in this regard. Thank you very much, Mr. Chair.
Thank you. I think very interesting presentation, sort of covering a lot of wide topics and areas. Let's see if we have any questions. We have a few minutes. Let me, go ahead and ask one. So the electronic avocados, right? I'm sure they would be
Yes.
very tasty to eat, especially for engineers. But then, how are they?
Yes, always.
Yeah. But how are they communicating to you, assuming that they might be in containers and other things, right, while going from one country to other? Or was it sort of you had to go again and then catch your avocados to get the data out of it?
It's a very appropriate question. Our first version, the ones that traveled now, they still have SD cards on the avocado themselves. So we have to get hold of them in the end and then download the data. The transportation part on the vehicles, as well as the ship movements and the weather movements that influence the data, all of that were online connected through various systems. The next version of our smart avocados, we are working on a LoRaWAN version where we will be able to continuously online track the data. We've got quite a large LoRaWAN installation on our current campus where we are developing some of these technologies to get to that point that we can actually trace that avocado exactly where it is at any time. Currently, we get it from the GPS data later on, but that we can online trace it. And the important part of that data is to identify that location or event which actually causes possible damage to the fruit that is being transported, because that is what we want to prevent in the bigger picture.
Sure. Thank you. I think let's just wait for a few more seconds if there is any other question from the audience. I think Professor Mukhopadhyay is requesting to be unmuted. So if host can do that, I think he probably wants to ask a question. Yeah, Professor Mukhopadhyay, I am not the host, but if you can type in your question, I can, unless the host unmutes you.
Yeah, all participants are unmuted now.
Okay, that might be.
Yeah, thank you, sir. Yeah, Professor Stein, it was very interesting, your talk. You know, I mean, I'm an electrical engineer, and this road and vehicle thing, we tend to always think about the vehicle. So my question is, and just because you brought in a lot of social and try to relate it with life. So vehicles are becoming communication enabled. So just like a human being carries cell phones, I mean, very soon I think a lot of vehicles are going to be connected. And then you are going to have a lot of data, not only about the vehicle, but also about the roads. So do you think that would be a great opportunity?
Very, very good question. Because if you look at the developments in the road pavement area, there's actually a lot of usage of this type of data that previously we had to have dedicated vehicles with sensors to collect a lot of this type of data. Things like the riding quality of the road. You had to have a very dedicated, expensive vehicle, and typically in a normal road department's life, you will measure that data once a year if you are lucky, and then you know what the road condition was in the last year. A lot of the current telematic type of information, and there's various of these available, we can collect that data online on the fly constantly. So I can tell you this afternoon what the condition of a large network of roads is this morning based on a calibrated set of data from cell phones, telematic devices, and various others in these vehicles. And the benefit of this is that we start to get maintenance and rehabilitation related data much quicker. I don't have to wait for the next year cycle to obtain that data. That support my maintenance and rehabilitation decisions, which makes it much more strong. But the more important aspect for me is that it allows us to provide much better road safety. Because, for instance, some of the work that we have done, we looked at how a vehicle responds to traveling through a pothole, for instance. And you get a very distinct, unique signal from the accelerometers that you've got in the vehicle. So I can see if there's a new pothole that formed last night. I can see this morning that there is a pothole, where it is located, and my maintenance team can be there before lunchtime and make sure that this road safety aspect gets a lot of attention and we sort it out. So that aspect of being able to collect hosts of data on the fly is a major benefit to road transportation engineers. Obviously, we need different techniques. We need big data and data analytics and all of that, because you cannot just take that data anymore and plug it into a spreadsheet and think that you've got space and the capacity to understand this host of data. But I think that's a real challenging part in terms of the transdisciplinary discussions, where you've got the road engineers that understand what's the story of a road, you've got the mechanical engineers that understand how a vehicle responds, and you've got the data analytics and data scientists that shows you how to put all of this together and how to get to a good answer which supports the community's safe and economic transportation as quickly as possible.
Yeah. So, yeah, thank you. I think, sorry, I have to interrupt the interesting discussion which is going on as we are running out of our sessions.
No problem.
So, yeah, thank you very much, all the speakers and participants for actively contributing to this session. So, I think now we have a 10 minutes break before we start for the next session. I'll give it back to Professor Amit Agarwal if he has some announcement to make.
Thank you, everyone. We will take a 10-minute break and then we can come back.
Yeah, but I'll have to leave, Professor Agarwal. I have a condolence meeting to attend. Thank you.
Yeah. Good morning, Professor Antodo. We are just taking a 10-minute break and we'll start the session in another 7 minutes. Actually.
We may start now.
Okay, President, just hold on to the 4
Okay.
minutes. Start at
Okay.
5.
Okay. Thank you.
തമ്മിലെ കടന്നു കുട്ടി എന്നാ പറയുന്നത് അതൊക്കെ എല്ലാവരും അവിടെ തന്നെ നിൽക്കുന്നുണ്ട് കാണുന്നത് കുട്ടീനെ കുട്ടീനെ തട്ടിപ്പോ
So welcome back to the fourth session of this very interesting Listen New World Conference. This session is going to be chaired by Professor William Paul, who is Professor at the Kappa Institute of Social Studies. What do you think?
Thank you, Professor Amit. This is an interesting session. This has 3 papers. To start with, we are going to start with Mr. Adalberto. Adalberto is going to speak on a very interesting topic, that is sustainable, that's on electric mobility in Brazil, public policies and market growth. Mr. Adalberto is president of the Brazilian Association of Electrical Vehicles and BYD's director in Brazil. And it's going to be followed by the second presentation. That's also very interesting. It's from Russia. It's going to be presented by Vladimir Klintra, the Department of Innovative Technologies for High-Tech Industries, National Research University, Moscow Power Engineering Institute, Russia. Dr. Vladimir is going to talk about research and development of promising hydrogen technologies. The third presentation is by Ms. Lesigo who's from Trade and Industry Policy Strategies, South Africa. And the theme she's going to deal with is harnessing electric vehicles for industrial development in South Africa. So we start with Adel Berto. So I think the format you may be familiar with. It's 25 minutes, 20 minutes for presentation, and then 5 minutes for question and answers. I invite once again Mr. Adel Berto.
Hello, Professor Bino. Thank you for the invitation, the opportunity. Professor Amit, also Professor Richard. It's great to be here with all of you. As president of the Brazilian Association of Electric Vehicle, let me just share a little bit some slides about how the market is growing in Brazil. Unfortunately, are you seeing my presentation?
Yeah, it's getting shared. It's being shared. Yeah.
Your voice is not very clear, though.
Unfortunately, Brazil still don't have a national level program to foster electric vehicles. The federal government has not been too keen on this. You know, Brazil has biofuels. We are just like India, big producer of sugarcane. So this has held on some momentum. But we are seeing a lot of good public policies being done under the subnational government. So the Brazilian Association of Electric Vehicle gathers a lot of companies, not only electric vehicles and auto producers, light vehicle, bicycles, and trucks and buses, but also a lot of components, infrastructure, energy companies like energy utilities, rental companies, light rail solutions. So it's a big ecosystem to foster this. We divide ourselves in different areas. Micromobility has been one of the areas that grew first in Brazil. There were a lot of bike shares and scooters and, you know, all these small applications. They were concentrated in big cities. São Paulo had the biggest project, you know, Rio de Janeiro, all the large cities in Brazil. A little bit before COVID, we already saw some problems into this, some of this business, a new business model, because some cities started to regulate it too much, they grew too fast, and what happened was that some of the companies merged, you know, some systems closed. When the pandemic arrived, it hit it really hard on the share mobility. Light vehicles, as you all know, Brazil has been a big player all worldwide. We became the 6th largest producer of cars a couple of years ago. Then we had a big financial and economic crisis.
Mr. Adalberto, I request, can you move closer to mic? Now this voice seems to be a bit feeble. Thank you.
Okay, sure. Maybe I'll put the volume up. Maybe the volume was not that high.
Oh, that's fine.
So on light vehicles, Brazil used to be a very big market, the 6th largest market. During the 80s and 90s, Brazil became an important industrial hub. Our industrial activities grew faster than the rest of the world. But from 2000, after 2000, 2010, now going to 2020, we are passing through a big disindustrialization process in Brazil. We had very liberal governments in the last, 20 years, even when some of more the left governments were there. We continue with some of these liberal activities, which made the industrial park to melt down in Brazil. So cars represented 5% of GDP in the past. Now they represent less than 3%. We do have a big production yet. We have 5 million cars production capacity, but we are producing half of this. 2 million, 2.5 million. Our focus has been more on small cars, 1.0 cars, flex fuel, so they can use ethanol and gasoline. But this has been made more difficult for the electric vehicle local production to start. Infrastructure is something that moved a lot in Brazil. There were two big R&D projects of the National Electrical Energy Agency, ANEL, Chamada 21, Chamada 22. And the last one, for example, the first one was on storage, but also included some electric vehicle. And the last call, which was focused on electric mobility, we had more than 600 million reais, so something like $120 million in investments in infrastructure, in R&D, in new projects, and these projects are being developed right now. So heavy-duty vehicles have also been an area which we grow. We have local production. Brazil has always been a great producer of buses and trucks. We do have a lot of projects with electric vehicle. There's a big Chinese manufacturer, BYD, here producing, but there's also Brazilian companies producing, like Electra. Volvo also started with hybrid. Now Volkswagen, MAN, also starting with trucks. So slowly, these projects are moving. And they are bringing new applications. So we see logistics. We've seen shared fleets for logistics, for bicycles, and police. For example, here there is one city in São José dos Campos that 100% of their police cars are electric cars. So, well, we all know the trends that were even before COVID, you know, with smart economy, economy of things, IoT, and everything else. There has been a huge transformation on the electric sector with the energy utilities realizing that electrification is really big process, part of this process of digitalization, decentralization. So energy utilities are being the leader in Brazil, not only in Brazil, in Latin America too. We see, for example, Chile now. Santiago have the biggest electric bus fleet outside of China. And this fleet has been purchased by energy utilities, which then later rent to the bus operators. We are seeing the same process in Colombia. Colombia, only Bogota, bought more than 1,500 electric buses last year to be delivered this year. So it's a big change. Also here in Brazil, there's a good ecosystem of innovation around the electric car in order to have a more shared mobility, a little bit more decentralized situation. And we believe that also in Brazil, there will be a newer smart energy system. Brazil energy matrix is considered very clean. We have big hydro plant, 70%. We have grown a lot in wind and solar. We have biomass that generates also 8%, the biomass from sugarcane, and also biofuels. So they complementary itself during the seasons of the year, during the day and the night. And we believe that that old system of generation, transmission, distribution, and consumers is changing rapidly in Brazil because of these investments in the smart grid. So that we have more and more the pro-consumer. Consumers that can use electric cars to take out their houses from the grid, that can use second life batteries. Unicamp, University of Campinas, have a big project with CPQD and CPFL, the energy utility, now owned by State Grid from China. They're doing a big project of using old batteries for electric vehicle into the grid, into solutions for solar, off-grid. So this process is also changing in Brazil. We're seeing this ecosystem growing more than doubling every year. At the association, for example, we have double the amount of associates in the last 2 years. And mainly, a lot of these new associates are small companies, startups of innovation that are trying to bring this. So in India, you know, in South Africa, all the rest. If there are companies that want to test and try the developments they are doing, Brazil is a good place because these startups are putting in practice now their developments. So we as Association of Electric Vehicle, we can help to match companies in order to do this. So let me talk briefly about the market for electric bikes. Of course, China, India, you know, two-wheelers, it's a much bigger use than for us. But bicycles have traditionally been very small into the modal share in our cities. Smaller cities can have 5% modal share in bikes and no motorized transportation modes. But in big cities in Brazil, like São Paulo, Rio, or in Brasilia, Salvador, bicycle has only been like less than 1% of modal share. But we are seeing that historically, local production and sales of electric bikes have been growing. We estimate that this year it will grow to up to 40,000 units. It's not that much. I understand that India or China, the volumes are much bigger than this, but at least it shows a trend, you know, that the market is growing, electrical bikes. We just had the first lithium battery facility assembly in Brazil last year. So slowly, I think the market is growing. When we talk about cars, as I said before, there has been a long time attempt in order to foster hybrids, plug-in hybrids, and battery electric vehicles. But the incentives were really small, you know? Like in the past, Inovar Auto used to be our auto regime. We had import tax reduction for hybrid, for battery, some energy efficiency targets. But up to 2018, the market was very, very small. Then in 2019, when we entered the new auto regime called Rota 2030, we started to have local production. So Toyota started producing hybrid vehicles in Brazil. So you see that in 2019, there was a little growth. 2020, even bigger for a hybrid. But when we consider electric vehicles, pure electric vehicle, battery electric vehicle, you can see the little green dots. I don't know if you can all read, but they're very small numbers. We are talking about 800 units last year of pure electric vehicle. So for me, as president of the Brazilian Association, this number cannot be acceptable because we used to be the 6th largest economy in the world. Okay, now with the economic problems, you know, as you all know, since the commodities fall down in 2012 to 2015, we entered a big crisis in 2015 and 16, 8% down GDP. There was a little growth in these other 2 years. Last year with the pandemic, GDP down. But the reality is that electric vehicles still pay more taxes in Brazil than normal gasoline cars or ethanol cars. This is not acceptable. But unfortunately, that's our reality. Especially now, Brazilian federal government has not been a leader or a champion in environment. They don't really care too much about environment action. So we don't have national sustainability frameworks. We don't have national goals. We don't have things. What we're seeing is the leadership of mayors. So the mayor of São Paulo, the mayor of Rio, they all commit to, for example, São Paulo has a climate change bill that will change 100% of the electric buses or fossil fuel free buses by 2030. Rio de Janeiro just announced a very ambitious climate change bill. So this is happening in Brazil under subnational governments doing. So the market for hybrid will continue to grow, but unfortunately, when we see, for example, battery electric vehicle, we are the leaders of the Latin American market, of course, because we are so much bigger than everybody else. Our car market last year, 2 million. Remember, we had a market of 4 million before, okay, 4 million cars. Colombia has 10 times less. Costa Rica have 100 times less. But Costa Rica and Colombia, like Chile, Ecuador, and Peru here, all of them have national targets for electric mobility. All of them approved national strategies, and there have been good money and good public policies to foster these markets. In Brazil, not too much. So although we have a clean energy matrix, 83% of our matrix is renewable. We sold 5,000 plug-in hybrids, 13,000 hybrids, and only 800 battery electric vehicles. So the market last year in Brazil, let's call new energy vehicles, hybrid, plug-in, and battery, became 1% of the market. 20,000, 2 million, you know? And now from January to April, this number went from 1.6%. So it's a little bit increase, you know. I think here in Brazil, we have an expression, you can see the glass half full or half empty. Until last year, we were seeing the glass half full because some things were happening. But this year, with the growth of electric vehicles all over the world, China increasing more than 300% battery electric vehicle only this year, Europe doubling electric vehicles last year, US now with Joe Biden's $2.3 trillion project, you know, big money, 600 billion for electric vehicle. Now we are starting to see half glass empty. We believe Brazil can do much more public policies than what we have now. For now, as I said, there's only local government policies. There is not a national framework. I also understand India has made bold announcements for electric vehicle. I'm pretty sure you are going to do very much better than Brazil because of this reality. But I hope that very soon Brazil is back to the game. For everybody to know that our auto regime from 2013-17 in Novar Auto was very effective in attracting investments. There were many new factories opening. So we had a 5 million capacity, the market growing. But since Rota 2030, that started in 2018, without incentives for electric, remember, electric vehicles pay more taxes than a gasoline car in Brazil. That's crazy, crazy, completely crazy, but it do. So in the last years, what we have seen last year, 4 factories closed down in Brazil, including Ford, that was here for more than 100 years. So this has hit a lot, the market. Last year was created the National Platform for Electric Mobility, a project PNME. I'm part of this platform, financed by the German government. And the platform has slowly started to introduce public policies, create a framework for the system. So we believe that somehow in the next months, there will be new public policies. We had a meeting yesterday with the Minister of Economy, telling them, look, the situation is crazy. You know, we cannot continue to overtax electric vehicle while the rest of the world is fostering and giving incentives. So hopefully things will change in the near future. I'm pretty sure that Brazil has a great potential just because of the size of the market. Mercosul has some of the biggest lithium reserves on Earth. Right now, Australia leads the production, but Brazil, also Chile, Argentina, Bolivia, we have big lithium production. So we believe that Brazil can win a lot in growing the electric vehicle market, integrating all these technologies with biofuel. We believe there's a good opportunity for biofuels with plug-in. There will be new cars launched this year in Brazil, flex fuel hybrid, where we believe plug-in can enter. So unfortunately, I would like to have better information to share. I would like to have better numbers, but the reality is the reality. You know, unfortunately, sustainability has not been a big issue, governments in Brazil, and this impact the industry. When I was born, the beginning of the 80s, industry, transformation industry represented 35% of GDP. Now it represents 10%. Last year, exports of commodities, food and mineral became more than industry. Together, agriculture and mineral exports are more than the industry in our GDP. And last year was the change. So unfortunately, our politics, our Congress, they are led by people from agribusiness. Politics has not been really considered industry in the framework. So this has been affecting really, really bad the situation of our industries. And I hope that electric vehicle becomes something important for us too. Thank you.
Thank you, Mr. Adalberto. The presentation was quite interesting one. I'm sure it's going to generate very interesting perspectives. Please share your views in the chat box. I can read it out. But prior to that, Mr. Adalberto, I have a question to you. As far as public policy is concerned, do you have perspectives, or have you really been articulating, particularly in Brazil, perspectives on total cost of ownership? Because that's a game changer. That's entirely different when you compare that with conventional marginal costing or cost of operation. Is that in your mind, cost of ownership?
Yeah, a lot of companies are starting on logistics, are starting to grow electric vehicles. So this year, now in June, just 10 days ago, there was the biggest registration of light commercial electric vehicles in Brazilian history. Because logistics, especially with the increase of e-commerce, logistics is really playing a role in growing the market. The TCO, the total cost of ownership, is favorable for this. Also, big trucks, waste management systems. There are something like 60 trucks in Brazil, which is not bad considering the rest of the world. Rio de Janeiro, for example, have 10% of their waste management truck fleet electric. The TCO is favorable for big trucks. Buses, the TCO was good. Just by 1 year ago, 2 years ago, in 10 years operation, electric bus was better on the TCO. But unfortunately, with the increase of the dollar, and electric buses are mainly with imported components, now the TCO doesn't look that good. And the TCO for light vehicles in Brazil is really, really difficult. I showed some numbers that we sold something like 19,000 vehicles. Out of these 19,000, 17,000 are luxury cars. So luxury cars, the impact of price doesn't matter. And they already pay gasoline cars, a Porsche, Audi, you know, like this big car. They pay high taxes for gasoline or diesel. So electric cars paying high tax is the same. But when we go to cheaper cars, cheaper gasoline cars pay very small tax. And electric cars, even smaller cars, like cheap cars, imported cars from China, for example, they pay a little bit more tax, so they are expensive. An electric car in Brazil costs 2 years and a half of the average income of Brazilian workers.
Okay.
So it had not been good. Of course, I would like to tell you that TCO is favorable, but unfortunately, the reality is not.
Thank you, Mr. Adalberto. Thank you. So now we move to the second presentation by Dr. Vladimir. So Dr. Vladimir, please. come to the stage. Yeah. Here
Good
we have
afternoon, dear
Dr.
colleagues.
Yeah.
Could you hear me?
Yes, Dr. Vladimir. Yes, perfect.
Good afternoon, dear colleagues. My name is Vladimir Kindra. I am from Moscow Power Engineering Institute from the Department of Innovative Technologies for High-Tech Industries. Thank you very much for the opportunity to give a speech. It's a great honor. The subject of my report will be, just a moment, I will share the screen. The subject of my report will be the research and development of promising hydrogen technologies. Today, hydrogen topic is very hot, and many countries trying to find a way to develop new perspective technologies in energy and transportation sectors. My talk will have I will give a speech with the next structure. So I want to start with the relevance of the transition to hydrogen economy in Russia, then give a brief description of hydrogen concept. After that, I want to talk about different power generation technologies, such as steam turbine power plants with hydrogen overheating, nuclear power plants with the same overheating, combined cycle gas turbines with hydrogen methane mixtures, and the last technology, oxy-fuel combustion power cycles with hydrogen methane mixtures. In the end of the speech, I want to share our experience about different transportation method for hydrogen, and also in the end of the speech, I will give a brief description of our future plans in the field of research and development of hydrogen technologies. So today, the development and implementation of hydrogen technologies is one of the key importance, not only in Europe or Asia, also in different countries and also in Russia. So we have one big advantage. We are between two major centers of hydrogen consumption, European Union and China. So we have also unloaded nuclear power plants and hydroelectric power plants, which energy could be used for hydrogen production. Therefore, the Ministry of Energy has developed the roadmap development of hydrogen energy in Russia for 2020-2024, according to which Russia should become a leading producer of hydrogen in the near future. You could see here on the slide the investment which is necessary and the potential profit which could be gained per year. And the main future producers we expecting could be two big energy companies in Russia, like Gazprom and Rosatom. So in the Moscow Power Engineering Institute, we developed such concept map of hydrogen economy. Could you hear me?
Yeah.
Okay. In Moscow Power Engineering Institute, we have developed the concept, the map, which represent our concept of hydrogen economy in Russia. So we can see that hydrogen could be produced on nuclear power plants. That hydrogen is called yellow. On hydropower plants, on renewables like wind and solar. And after that, it could be transported by gas pipelines, which already exist in Russia, or by shipping in countries like Japan or Korea. Here you can see also the concept of hydrogen city proposed by our university is very close to the other concept which already developed by other universities. So the hydrogen could be produced, as I showed here on the slide, by different power generation units, and it will be consumed by also thermal power plants, electric cars, or by oil refinement industrial enterprises. And I want to give some details on possible ways of usage of the hydrogen fuel on different power generation units. So the first technology is nuclear power plants with hydrogen overheating. The idea is that when the nuclear power plants should be unloaded, it could be the energy of it could be used for hydrogen production, and the obtained hydrogen after that could be used for electricity production, not only by the process of electrolysis, but also by steam overheating. This technology could achieve efficiency up to 40%, which is quite high for the nuclear power plants. Here on the slide, you can see the same technology, but not for the nuclear power plants, but for the thermal power plants. You could see special oxy-fuel combustion chambers, oxyhydrogen combustion chambers, which could be located in steam pump pipelines, main steam pipeline and overheating pipeline. So this solution allows to decrease investment for the thermal power plant because we could eliminate high consumption of heat-resistant alloys, which used for boilers, for steam pipelines, because the combustion chamber usually is located before steam turbines and very close to it. So the efficiency of such a power plant would rise up to 45% if we have initial temperature of steam, 840 Celsius degrees. However, there are some problems which could occur for that scheme, for that technology. It's connected with efficiency of combustion process in such combustion chambers, because the pressure is very high and a lot of dilutant, steam dilutant, which also affects the combustion process. Other problem could be is the increasing of flow in the low pressure turbine, because if you modernize a high consumption power plant, the mass flow of steam in the low pressure turbine will be already significant, and if we install additional combustion chambers, it will rise. So we investigate these problems, and we have already developed the construction of oxy-hydrogen combustion chambers. The results, we use numerical and experimental modeling for the development process. Here on the slide, you can see the results of numerical modeling, which are the contours for speed and the contours for temperature. The efficiency of such a combustion chamber not very high, it's only 98%, so 2% of hydrogen will not burn. It's a problem still for us, and the reason for it is that we should burn hydrogen in near stoichiometric proportion of fuel and oxidizer. The second solution, the second problem which we considered was increasing of low capacity in the low pressure turbine, as I mentioned before. So to increase the flow capacity of the biggest part of steam turbine, low pressure turbine, we could use the traditional method. So we could increase the blade length. However, we are limited because of the strength problem. So the possible way to deal with it is the creation of two-tier low-pressure turbine with a special penultimate stage which have a blade with a fork shape. So it's very unusual, and this blade was created at the Moscow Power Engineering Institute. So such a low-pressure turbine would have the same blade length like the traditional low-pressure turbine, but the capacity will be increased by 40%, which was quite significant and could solve the problem of increasing of flow in low-pressure turbine. The second technology which we also considered is the usage of methane hydrogen mixtures in combined cycle gas turbine power plants. So when we mix hydrogen with methane, we change the parameters in cycles. The gas turbine outlet temperature will not decrease significantly, but the efficiency also will not decrease significantly. The power will decrease by 1%. The efficiency will not. The reason for it is the increased content of water steam in the flue gases. So we also considered, we also investigated the process of combustion, which the results of which I show later. The last technology for electricity production and one of the most promising is oxy-fuel. Oxy-fuel technology, here you can see a cycle very close to alum cycle, well-known alum cycle, which was developed in 2020 by the Rodney Alum, and the power plant of which is now situated in Texas, in the United States. So, but it has some features which haven't been considered before. So we also added some unit for ammonia production. Ammonia is necessary for transportation of hydrogen. It's a very cheap way for transportation of hydrogen if for the big distance. So this unit integrated by the usage of nitrogen produced by air separation unit. Here you can see this link. After the production, we also could transport some ammonia, and some hydrogen would be burned also in oxy combustion chamber. So here on the slide you can see this kind of combustion chamber which could be used for oxy-fuel combustion. It has several zones: flame stabilization zone, zone for cooling, and mixing zone. So it's quite traditional. But the results of investigation are not very traditional for that combustion chamber. So when we model the oxy-fuel combustion, we found out that yes, it's well known that the hydrogen have a high flame propagation speed, but the carbon dioxide, which is the dilutant in oxy-fuel combustion, reduce significantly the speed of propagation. And if we compare the combustion in nitrogen diluted and carbon dioxide diluted, the propagation speed of hydrogen will be much lower in the carbon dioxide. However, hydrogen has a bigger flame of propagation. So if we compare oxy combustion, oxy-fuel combustion chambers with traditional gas turbine combustion chambers, this flame of propagation will be near the same. And after we have considered the technology for hydrogen production and for hydrogen usage, we also wanted to investigate the possible ways of transportation. We have considered well-known ways like compression of hydrogen, like liquefaction of hydrogen, and also ammonia method. So we found out that if the distance will be higher than 2,500 or 3,000 kilometers, the ammonia way of transportation is the cheapest. So it's it's one of the cheapest way. Also, the storage of hydrogen in ammonia is also quite competitive compared to others. So that's why we use this method in oxy-fuel combustion power cycle. And in the end, I want to say that in the future, Moscow Power Engineering Institute will plan to increase our investigation in the field of hydrogen technologies. We have already created new institution for the hydrogen investigation. This is I showed you only a little part of our results which we have already achieved. So in the future, we want to develop an effective and low-cost technologies for hydrogen production. Also, we are doing research on hydrogen storage and transportation methods, and research in methods for usage of our hydrogen. So in the end, I want to say that we are very interested in cooperation, and if any of you just wanted some kind of cooperation, just contact me or my colleagues. We will be very interested and glad. Thank you very much for your attention.
Thank you, Dr. Vladimir. And you presented visually complex research you've been doing, and it was quite informative and enlightening. Because I'm not technically research-wise competent to ask questions, etc. I think our participants would like to have some reflections. Please share your views in the message box. Leave your message in the message box. I'll read out. Anyway, that was quite a wonderful presentation, Professor Vladimir, on techno-economic feasibilities of set of technologies and setting an alternative technological agenda. That has been immensely useful and great. Any questions? Kindly share your perspectives, questions in the message box. I can read out. Of course, Professor Vladimir, I'm sure it's going to ignite a lot of energies. So I'm sure our fellow scholars will be in touch with you.
Thank you very much.
Professor Vladimir. Yeah. Now we move out to the next presentation, an interesting presentation by Ms. Lesico. So I invite Ms. Lesico for presentation.
Thank you so much. Sorry, I'm trying to share my screen.
Oh, sure.
Thank you so much, Chair. My name is Lesejo, and I am from South Africa. So I just want to say that I'm not an engineer, so I'm just a researcher. So my presentation will be looking at exploring policy options to support electric value chain development in South Africa. So before I start, I just want to say thank you so much for the opportunity to have me present our very important work that we have done with the Automotive Association in South Africa and also with the South African government. So I'm very excited to share some of our findings and research with you guys. So in terms of outline, I'm going to be looking at market development. So this will be passenger cars and public transport, and also looking at industrial development, where we're looking to vehicle manufacturing of EVs, and also in developing the supply chain, which obviously includes component suppliers as well, particularly tier 2 suppliers and also tier 3 suppliers. So we all know that the electric vehicles revolution is underway, and EV sales are growing exponentially and faster than forecasted. And we've also seen the traditional OEMs entering the market in one form or another, but also we've seen new and diverse players also entering this this very exciting space of e-mobility and of electric value chains. And when it comes to South Africa, unfortunately, we are lagging behind global trends, and we think that it's really important for us to act now in order to become relevant, in order to maintain our competitive advantage. And so that's why we've identified that it's so important for us to develop passenger cars and public transportation as well. So in terms of the market development for passenger cars, in South Africa, I guess, like Brazil, the stock of electric vehicles in the country is very, very low. And one can say that it's insignificant. I think, last year in the country, we had about just over 2,000 electric vehicles, and this includes full battery, it included plug-in hybrids and hybrids, but we currently don't have any fuel cell vehicles just yet. And one of the reasons for the insignificance of EV sales in the country is that there's no incentive for customers, and there's also a lack of awareness in terms of the importance of electric vehicles. And also there's the substantial capital cost premium on electric vehicles, which make them relatively a lot more expensive than the ICE counterparts, for example. So because of those reasons, it's been it's very difficult to get the country to uptake electric vehicles. And obviously, when you speak about electric vehicles and uptake, there's also the issue of infrastructure, right? And of range anxiety. But then in South Africa, because of the fact that we have very few EVs and a lot of charging stations, we find that charging infrastructure is actually sufficient given the number of EVs that we have in the country, right? And one can actually travel from, for example, Johannesburg all the way to Cape Town with a full battery car and be able to charge as well. But then issues of range anxiety still exist because there's a lack of awareness about these charging stations, and there's a lack of visibility. And also there were concerns around standardization of charging infrastructure, but those have now been sorted. But then in South Africa as well, we also have issues of blackouts and of electricity prices increasing. So then when it comes to I guess developing electric vehicles in the country, those are concerns, because if you buy electric vehicles and there is blackouts, then it'll be very difficult for people to want to partake in this revolution, because it's like, if you buy an electric vehicle, then it'll be very difficult for you to actually charge the vehicle as a result of the blackouts that we have in the country. So those are very valid and key concerns that most potential customers have with regards to passenger cars. And so in terms of policy, we've identified 4 key areas for primary intervention. And the first area, or the first option, would be, for the country to change its value-added tax, or ad valorem. And, we see this as being impactful. However, the question then would be, how do we justify it? Because in essence, it would seem as if we are subsidizing the rich, which could obviously be very difficult to justify, right? Because, we are talking about luxury vehicles. Well, especially in the case of South Africa, because we don't really have any, cheap electric vehicles like, your China, for example. The second option would be to look at custom duties and to provide a level playing field that addresses an anomaly that we have in South Africa, because in terms of importing full battery electric vehicles, BEVs from Europe attract a 25% import tariff, whereas BEVs from any other country would attract an 18% tariff. So then we see that as very important for policy to try and level that playing field and address the anomaly. But also, there's no guarantee of reduced prices for customers, if that was to happen. Another option would be preferential finance, and this could be done by partnering with financial institutions and hopefully providing cheaper credit, right, for households. But then again, another problem is that could be regressive, because, it could be seen as providing cheap credit for rich income household, which again would be, difficult to justify in a very unequal society that South Africa is. And then the fourth option that we have is fleet level targets. So we see this as being very important, because this would send the right signal for market development, right? And we'd also need to make sure that we get the target right, because we don't want a target that's too low and shoot ourselves in the foot, or a target that's too high and unattainable. As an addition to the primary interventions that I spoke about, we also have what we call complementary additions that would go with the primary interventions. So these are not beneficial by themselves, but they are complementary. So, in order to reduce, the price differential gap between EVs and ICE vehicles, we could look at things like reducing license costs for EVs, for example, or having preferential insurance rates for EVs, for example, or also, increasing parking for EVs as well, or offering free parkings. And also we have non-financial incentives as well. And, in terms of, again, market development, we've identified that public transport is very important to look at. And this is where we see the most impact in terms of the EV rollout being important in, because in South Africa, public transportation is very, very important. Almost over 50% of households use public transportation. So when one speaks about e-mobility and also inclusive development and the just transition, we see it as it being very important for the rollout of e-mobility to really prioritize public transportation. And similar to the passenger market, we've identified a couple of interventions for boosting public transportation in South Africa. And again, that will be changing the value-added tax. But then in this case, it will be a lot more justifiable, because, now you're targeting low-income households, right? And so the impact is much larger. And then another option in South Africa that we have is that we have this program. It's called the Taxi Recapitalization Program, which is a program that supports the introduction of minibus taxis. So then that could be used in order to leverage that existing program in order to introduce minibus taxis in the country. Another option, again, is preferential finance, and then also the option of public procurement. However, this will require proactive and resourceful Munichs. And another thing is that we've identified that it's, in the short term particularly, it's very important for the technology to be neutral and to be technology agnostic. However, in the long run, we would propose that support for EVs is increased while the support for ICE vehicles is actually reduced. So again, in terms of market development for public transport, we have these primary interventions, but then we also have what we call complementary interventions or complementary measures. And for public transport, we could look at, for example, fuel costs and look at charging. So then for public transport, you could provide either free charging or either provide preferential rates when it comes to charging. And then we looked at industrial development as well. And in terms of industrial development, we looked at vehicle manufacturing and also, as I previously mentioned, supplier development, which is more looking at components of cars. So when it comes to vehicle manufacturing, South Africa is a big player in the global automotive value chain. And it's ranked 22nd in the world in terms of its production, so and you find that about over 50% of South African vehicle exports actually over 50% of South African production is exported, and that is mostly exported to Europe and the US. So, in order for the country to remain competitive and to not lose out on its key markets, it's important for South Africa to move towards this e-mobility revolution, and to move towards manufacturing, or rather for the government to move towards providing policy support for manufacturing electric vehicles, because that is something that we currently don't have in place. And so in terms of developments when it comes to vehicle manufacturing in the country, we have, there are a lot of conversions that are happening, especially in public transport with regards to buses and also with regards to minibus taxis as well. And there are also developments around buses with BYD and the city of Cape Town forming a partnership to develop e-buses in Cape Town. But then you also find that there's also the only OEM in the country is Mercedes, and they're manufacturing plug-in hybrids, but these are manufactured exclusively for the export market because there is not much local demand for such vehicles, so hence most of them are exported. So when it comes to primary interventions for vehicle manufacturing, we've identified 3 options. So the first option would be a very straightforward option, and that is to use our automotive policy in South Africa. It's called APDP. So that would be a policy, thank you. So that would be a policy used in order to try and support OEMs and give them incentives in terms of, trying to stimulate manufacturing in the country. And then another option would also be fleet level targets. And again, we believe that this would really send the right signal to the market. But then, the downside to that is that it might actually not trickle down to manufacturing. And then we also have, developing the supply chain, which is very important, especially in the South African context, because, this includes component suppliers, mostly SMMEs, mostly Black owned, and mostly in tier 2 and tier 3 levels as well. And these are important because these are, suppliers that are often, able to unlock employment opportunities, which is something that's, again, very important to South Africa. So when we look at the value chain for EVs and ICE, we see a lot of overlaps, but then also, there are components that are EV specific, and we see South Africa as playing a role in that. But then it's also important to, for us as a country, to identify where we can actually have a competitive advantage. And we've identified that we can actually have a competitive advantage in mostly lithium-ion battery manufacturing, because we do have some of the lithium-ion battery-related reserves, and some are actually broadly available in Southern Africa as well, such as your lithium in Zimbabwe, and also cobalt in Zambia, and also in the DRC. And in South Africa, actually, when it comes to mineral beneficiation, there has been mineral beneficiation to battery grade, where South African companies are actually beneficiating lithium-ion battery minerals to battery grade. And this includes manganese and also aluminium as well. So again, this just speaks to, why it's important for South Africa to move towards, manufacturing EVs and EV components, because you find that, so currently our top components are very ICE specific, and those are catalytic converters and engine parts. And again, these are going to Germany and the US, and these are markets that are rapidly, moving away from ICE, and they've also, implemented policy that says that, in a couple of years, they will ban ICE vehicles. So then, South Africa is at threat from actually not being competitive. So that's why it's very important for us to move towards manufacturing electric components. And there are companies in the country that are in lithium ion battery assembly and manufacturing. We also have companies in charging infrastructure, and we also have a company called Isondo that is also looking at manufacturing fuel cells. So again, we have primary interventions that we can look at, and that again is modifying the APDP, which is the automotive policy. We also have mineral beneficiation, which could be very important, because then we could look at import and export tax, or development and pricing, which would make the minerals much cheaper for local manufacturers. But then I think it's also important to consider that the availability of raw materials in South Africa and in the region, although they provide a basis to look at, for value chain development, and they provide a comparative advantage to South Africa, it is not necessarily a competitive advantage if we don't have the investment, if we don't have the R&D, and also if we don't have the skills development and also the market access. So those are very, very important to think about as well. And then just going to conclude quickly. So, when it comes to policy, we see the development of e-mobility as being a multifaceted endeavor. And we think that it's important for the country to craft a policy framework that is aimed at fostering the sector, and we are very well aware that this requires the consideration of multiple angles, right? However, it's important for the government to send a very strong signal to OEMs in order for them to kickstart the development of EVs in the country, because as I mentioned, this is a very important industry in South Africa, and we really can't afford for the industry to not be part of the global trend and to be left behind, because there's just been so much investment in this industry, and it's an important industry, as I said, in terms of employment. It's an important industry in terms of investment and also SMME support as well. So I'll just stop there. Thank you.
Thank you, Ms. Lesiho. Very insightful presentation on industrial development, particularly for electric vehicles. And also you really dealt with supply chain, length and breadth of it. And also you touched upon the heterogeneous geographies across South Africa. And you were trying to articulate some kind of perspective for small and medium enterprises as well, which is the core part of the whole supply chain. I think our friends would articulate their question in the chat box. In the meantime, let me put a question, a perspective. I would be happy to hear from you. You spoke about supply chain. It's quite interesting. Now the question is, when it comes to OEM, original equipment manufacturer, component supplier relationship, what kind of image you have in South Africa? Is it like very strong OEM, relatively weaker component supply, or is it balanced? So when it comes to EV compared to internal combustion technologies, are you going to see a different dynamics in the value chain?
Thank you so much for the question. So our automotive industry is actually very similar to that of Thailand and that of India as well, actually. So you have a very strong presence of OEMs and tier 1 suppliers, whereas when it comes to tier 2 suppliers and tier 3 suppliers, those are often very weak. They have very little support from government. And also, when it comes to investment, they have very, very little investment. So then, in terms of the automotive policy, there's what we call the South African Automotive Master Plan that's coming out for 2035. Sorry, and it's really put an emphasis on localization and also on local content. Because previously, and I mean, still now, there's a lot of support that is going towards OEMs and large tier suppliers, but those are obviously mostly are mostly connected to the global value chains. And when it comes to unlocking, opportunities, again, such as, employment and supporting SMMEs and supporting, Black businesses, you find that OEMs and large tier suppliers, are not mandated to do that, right? So then that's why it's really important to unlock opportunities for smaller tier suppliers. And in South Africa, I mean, especially when it comes to battery manufacturing, battery assembly, what we found, especially in the lithium ion space, is that the companies that are actually doing most of your, so we don't do any battery cell manufacturing at all, but we do battery assembly. And most of the companies in battery assembly are actually SMMEs, but the unfortunate thing is that they're not currently getting any government support. So it's very, very important then for us to, really push that government supports these really small players so that they can grow.
Thank you. Thank you.
Thank you so much.
Thank you. Any questions before winding up? Anyway, we had very interesting, powerful presentations and very interactive sessions. So here we end. On behalf of the conference, I thank you, each presenter, for your wonderful presentations and insightful discussions. Thank you.
So thank you
Over to
session. And today we had presentation from all the 5 countries. I would like to thank the speakers for their excellent presentations and to the session chair for taking the sessions in time. While it has continued to rain here heavily while these sessions were going on in right? We have very heavy rains here. And so tomorrow we will come back. We have a very interesting session on discussions and way forward. So how the 5 Brics countries can do something together. So that is one of the sessions that we will have along with several other sessions. So I would look forward to welcoming you tomorrow on day 3 of the conference. So till then, good night. Stay safe.